Hi, today I'm going to show you how to make an obstacle avoiding robot. For this robot we're gonna need an Arduino Uno or Nano, some perf board for making the connections to the Arduino Uno or Nano, and another perf board for making the robot's platform, which is around 12 by 12. It doesn't need to be precisely 12 by 12. If it's like 10 by 10, 11 by 12, 12 by 13, 13 by 13, you can also use that, but make sure it's not longer than 15 by 15. After 15 by 15, it's gonna be like hard to maneuver the robot with only 2 motors, which is what we're gonna be using today. Just only 2 motors and a small little maneuvering wheel that doesn't have any connections to electronics. It's just passive. So yeah, just make sure that it doesn't exceed 15 centimeters when it comes to the length, especially of the perf board that you're going to be using. 2 little DC motors that have these gearboxes, as you can see, like this. We're going to be using all of these. We're going to be using these same motors on all of our robots. They're pretty cheap, pretty easy to get, and pretty reliable. And the other part we need is the L293D or B chip, and you can find the video that I made about this chip on how to use it, how it's used, and also showed how to use the L298N chip, which both 3 motor drivers have the absolutely exactly same usage. Their pinouts are almost the same, just the wiring schemes are a little bit different from the L293D and B and the L293, not the L293, L298N. So just the difference is just the wiring connections and the terminals and stuff like that. It's just the same chip that would do the same job. The only difference is the current capabilities, and these motors doesn't draw all that much current, but I'm using 7 volts to power these motors with this battery pack that you can adjust its voltage here. If you want to find more information about this battery pack, you can watch the video where I showed you how to make a light following robot, and I'm not gonna talk about this too much on this video. It's just a battery pack with a JST connector on it with an 18650 and XL2009. Not 2009, it's an XL6009, and it basically powers the robot. It basically powers the Arduino through the voltage in pin. So VIN pin is the Arduino can take from 12 to down to 7 volts from the VIN pin, which has this small little regulator. As you can see, you can also attach that voltage through the barrel jack, but I don't want to add extra weight to the robot. It's already heavy because it's a little bit complicated, and when it comes to the circuitry, the light following robot, this one was a lot lighter because it didn't have any Arduino, no coding. It's just a normal circuitry with a power connector on it, and it just goes. So I tried to make this as simple as possible and as neat as possible. This one is the motor driver connection going to the motor driver right here. The motors are directly attached to the motor driver, and the motor driver is attached with a chip socket so that I can swap it between L293D or B. I told you about the differences between L293D and B. They're basically the same when it comes to pinout, but the chip specifications are a little bit different, and I talked about all that on the video. L293D and B, how to use them. L298N, you can watch that video. It's very informative for these robots, for using these robots and making them. The other thing we need is an ultrasonic sensor that measures the proximity to an object. It basically sends ultrasonic waves through one output, and when it bounces back from an object, it measures that through the microphone, and calculates the time that it needs to go back and forth, and basically calculates how close the robot is to an object, and commands the motors to drive to a different direction. I pulled the code from a different source. I didn't write it, so I'm going to be putting credits for the channel that I pulled this code from, and I'm going to put the video that I pulled the codes from in the description. You can watch them, but their channel is in Turkish, so you may not understand anything if you're not a Turkish person. But yeah, the code is not from me. I didn't write it. I just pulled it from a different source. But I will be also putting the fritzing circuit diagrams in the description so that you can set up your own robot pretty easy with the code and everything. And the other thing is the way of attaching the Arduino Uno to the perf board right here. I just put a little piece of cardboard like this, attached a little bit of a velcro on the bottom of the cardboard, and attached the cardboard piece to the Arduino with these rubber bands so that I can just pull the Arduino and replace it with another one if I wanted it to, or just pull out the Arduino and use it for another project, so that the Arduino is not glued in, not screwed in, not damaged by in any way. So yeah, it's also attached to a little perf board like so to the connections of the robot. Let me just pull that and show it actually. There it is, the Arduino, the Uno. It's a clone, but clones also work perfectly fine. So let me just attach this back on here. And that's the power connector that I will be plugging the battery pack into, and I'm going to be putting the code and the description where I pulled it from for credits, and I'm also going to put the fritzing circuit diagram in the video description so that you can easily build your robot. And you also need a little bit of cables and soldering irons and all that. You can actually do this same robot without using any solder, no soldering iron, no nothing. You can just get a breadboard, and you can just, breadboards usually come with a double-sided tape on the back of them. Just stick it to the perf board and get an Arduino Nano and put the Arduino there, and make all the power connections and motor connections and motor driver connections and the sensor connections right on the breadboard. So you wouldn't need to solder anything. But I don't think it would be all that rigid. Like, some connections can get loose and the robot might break while it's driving. So I just prefer soldering. But if you don't have a soldering iron, you don't need to have a soldering iron. You can just breadboard on there and just set up the circuit like that. So let's attach the battery pack like so. Connect up the power connection, and let's test out our robot by flicking the switch. As you can see, it's seeing my computer right now. Okay, now it's not seeing anything. The motors are moving front, as you can see. But if I put an obstacle right here, it goes back. And then the obstacle's away, it still goes forward, obstacle, back, turn around, and go front. So let's test this robot on the ground. So I just made this small little testing area right here. These barriers are from old books that I don't use anymore and are not approved for sale, so I just ripped the cardboard parts off, like the book covers, and just stapled them together to make a little barrier like this. We're going to be also using this on the line following robot that is going to come up pretty soon on the channel. So yeah, two-functional barrier for like two robots. Anyway, so I'm just gonna switch on the robot and let's see what it does. Switched it on. As you can see, it's seeing the obstacle, going back, it's going front, seeing the obstacle, going back, going right back to us. There's a barrier under the camera, seeing that, going back, going front, turning around, going left and right. Seeing the obstacles. Okay, it's struggling a little bit there because this is like going down almost. This part of the barrier is almost like sinking down because it's thin cardboard, and I can't do anything about it for now, at least. Yeah, as you can see, it kind of got stuck there. Is it gonna save it? Maybe if I fix that barrier. Oh, I'm just gonna leave it. What is it gonna do? I'm just very curious. Let me just help it with the feet a little bit. Yeah, look at that. When the barrier is up properly, it's going back, as you can see. It's on the spot where the camera can't see it now, and as you can see, it's going. Is it gonna save it from that? Yeah, it does. Look at that. Pretty impressive, actually. Let me just help it a bit. What is it doing? I'm just gonna leave it alone. I'm just very curious about what is it gonna do. It's stuck on the barrier. It can't move. The motor is just stuck on the barrier. Let me just fix that. Oh, is it gonna save it? Is it gonna save it? No way. Wait a second. I'm just not gonna do anything. Just gonna leave the camera recording and see if it's gonna save that. There's no way that it's gonna save that. But if it does, I'll be really, really impressed. Come on, try again. No way, it's going pretty close to saving it. Come on, go. If it does one single maneuver, it can just save from that. Come on, do that maneuver. The barrier just dropped on top of the robot. Anyway, let me just fix that. That's not fair. Okay, that's better. Now it's still going. The battery voltage is a little bit low. I forgot to charge it before the video, so it's going a little bit sluggish. But normally it goes faster. A lot faster, actually. Look at that. Pretty good. Okay, so as you can see, it's really, really impressive. It almost saved that. Like, it kind of got squished on those two barriers in, like, front of those two barriers, and the barrier literally fell over the robot. It was almost gonna save that, but it didn't. But I'm still pretty impressed by this. Like, pretty good. The only thing it's really, really struggling with is this tiny, tiny little plastic maneuvering wheel, which isn't even turning anymore. It's like stuck in there. It's barely turning. Yeah, that's not good. If I like put a bigger one on there, it's definitely gonna go a lot better. Let me just turn this off actually. There you go. Yeah, the voltage regulator is a little bit hot because the motors are struggling because this robot is a little bit heavy and the motors draw a lot of current. The motor driver is really hot. And that's why I used the L293B chip, not the D chip, because I attached the D chip and it would like overheats so much to the point where it can't even drive the motors anymore. Like the motors would slow down so much that they can't even move anymore. So I just swapped it with an L293B, thanks to the pinouts being the exact same, and it just fixed that issue. So it just needs a little bit more of a powerful motor driver. I'm not going to attach an L298N on this robot, but on the Bluetooth robot, the Bluetooth circuitry and the other things, it's got like really good circuitry, but it's also very complicated, and it makes the robot very heavy. So I'm going to be using L298N on that. But for this one, this is like enough. L293B is enough on this. So yeah, pretty good, pretty impressive, and that's about it. Let's go to the table. So this was the robot. I didn't expect it to be performed that well, even with a flat battery almost. Like, I was pretty impressed by this performance from the robot. The code works wonderfully. I pulled the code from a different source. I'm gonna link it down below and add some credits to their channel. If you're a Turkish person that understands Turkish, you can watch their videos. They got really nice videos. And one thing I need to mention is I made the what was the sensor's name? HCSR-04 proximity sensors pins. I bent it 180 degrees. Normally it comes 90 degrees bent pins. Normally it comes with 90-degree bent pins, but I bent it back to 180 degrees, trying to not snap the solder joints carefully, and attached this little connector on there, glued it on there so that it would be more rigid. So if I attach the 90-degree connector on there, it's going to be like very fragile. Like if an obstacle hits it, it's going to definitely rip the connector off of that, because it's 90 degrees to the perf board. But since it's now 180 degrees, no matter how hard it hits to an object, it's not moving anywhere. Look at that. And on the old version of this robot, which has a video on the channel, which is really old video, the reason this robot broke down was the connector for the HCSR-04. It broke the connector. It ripped the connector out of the HCSR-04 from hitting way too much obstacles. Now it's like 180 degrees and the solder joints are good. I checked it and redid the soldering just to be on the safe side, like reflowed it, and yeah, it's pretty good. These sensors are pretty cheap though, so even if it breaks, you can just get a new one and plug it back in here. So yeah, this is about it for this video. Thanks for watching. If you find my videos useful, please consider subscribing to my channel, and don't forget to like my videos. If you share my videos to your other friends that has hobbies about electronics, it would really help me. It would really help my channel. So thanks for watching. See you on the next robot video.